Jeffrey Perez. I'm one of the geologists of the Philippines. First, sabihin na natin, there are very few geologists in the Philippines. So, baka wala pang 3,000 na licensed geologists sa Pilipinas. Ganun kakonte. And Dr. Payot have presented the importance of geology in the Philippines. But for my presentation, the title of my presentation is Searching for Old Earthquakes in the Philippines. We will not search for the one, but we will search for old earthquakes in the Philippines. And the tool that I will be using is Paleoseismology. As Dr. Payot has presented, the Philippines is a seismically active country. Every day, we are recording at least 20 earthquakes per day. So yung kulay red dots na nakikita nyo sa right now na mapa, that's the seismicity map or the earthquake occurrences in the Philippines. Every day, may earthquake, and this map is only showing earthquakes for the past 100 years. Hindi lahat ng earthquakes na nare-record ng PHIVOLCS are being felt by people. Around 100 to 150 felt earthquakes ang nare-record per year o nararamdaman ng tao, and for the past 400 years, we have 100 destructive earthquakes. The reason why we have earthquakes in the Philippines is because of our tectonic setting. As discussed, meron tayong mga trenches that surrounds the Philippines. We have the Manila Trench, Negros Sulu Trench, Cotabato Trench, Philippine Trench, and the East Luzon Trough. These trenches may generate a magnitude 8 plus na earthquake, plus it can also generate a tsunami. Within the Philippines, yung islands, you can see these red lines, and these red lines are what we call active faults. These active faults may move, it may generate a magnitude 7 plus na earthquake, and it is sometimes destructive. If you take a look at the history of the Philippines, yung written documents natin started when the Spanish came. So nagsimula yung history of earthquakes natin nung dumating yung mga Spanish. But prior to that, our forefathers, they have a concept kung bakit nagkakaroon ng earthquake sa Philippines. Ang sabi, kaya daw nagkakaroon ng earthquakes because of this Philippine mythology, si Bernardo Carpio. Si Bernardo Carpio, siya yung isang legendary figure in the Philippines. And ang sinasabi, doon daw sa bundok, sa mountains dyan sa may Montalban, meron dyan Montalban Gorge. Kapag daw tinutulak ni Bernardo Carpio yung dalawang side ng bundok doon sa Montalban, nagkakaroon daw ng earthquakes. So that's the Philippine mythology. In Japan, ang kanilang mythology about earthquakes is that kapag gumagalaw yung mga catfish, nagkakaroon daw ng earthquakes. But we all know that earthquakes are being generated by movements of active faults and trenches. In terms of history, makikita natin that in the past, the country has already experienced damaging earthquakes. And to prove that, you just look at old churches. If you visit mga historical and old churches, these old churches will tell us the history not only of the church, but also the history of earthquakes on that area. A very good example is the Manila Cathedral in Intramuros. So let's read the historical marker. Ang sabi, the first cathedral built in 1581, it was damaged by a typhoon in 1582 and then destroyed by fire in 1583. The second cathedral built of stone, so gawa na siya sa bato in 1592 and then partially destroyed by an earthquake of 1600s. So nung 1600s may malakas na earthquake na naramdaman sa Metro Manila. Third cathedral built in 1614 and destroyed again by another earthquake of 1645. Yung 1645 na event, isa siya sa mga earthquakes na I have studied in the past. This 1645 event is one of the largest earthquake felt in Metro Manila. That earthquake was generated by the Gabaldon segment of the Philippine Fault, and the epicenter of that earthquake was located in Gabaldon, Nueva Ecija. Gabaldon, Nueva Ecija is more than 200 kilometers away from Manila. Imagine the distance, bumagsak yung structures sa Metro Manila. What if ang gagalaw na fault is yung nandito lang sa Metro Manila? What will be the effect to Metro Manila? Hindi natatapos doon. Again, the Fourth Cathedral was built in 1654 to 1671 and then again destroyed by an earthquake of June 3, 1863. So yung June 3, 1863, based on our study, this 1863 event, yung epicenter niya is just offshore of Cavite. So nandyan lang siya sa tabi ng Cavite, sa may coastal area ng Cavite. And that earthquake not only damaged Manila Cathedral, it also generated a 1 to 2 meter high tsunami that inundated areas in Intramuros. So just reading this historical marker, it will tell us the past earthquakes in Manila that was felt in Manila. It will also tell us the possible tsunami that inundated some portions of Manila. Okay, that's on the historical earthquakes. The Spanish press, they have a very good documentation of our of the destructive earthquakes from 1500s up to 1800s or the early parts of 1900s. These are the possible sources of new old informations. We can look at local libraries that preserve these historical documents. Museums, there are archives in the Philippines. We can go to Spain. Yung mga reports ng mga priests during that time, the reports also included damaging earthquakes, damaging volcanic eruptions, and even typhoon. They are all well documented, and we can also look at other Southeast Asian countries with which we have contact during historical times. A very good publication that was published in 1946 is a compilation of Philippine earthquakes from 1589 to 1899. So the first recorded earthquake or the first documented earthquake in the Philippines was 1589. So a big question now is, ano yung nangyari before the 1589? Diba? Hindi naman meron tao lang dito nung dumating yung mga Spanish. We have civilization prior to the coming of the Magellan, meron ng mga tao dito. So, ano yung nangyari before 1589? To answer that, we can do a paleoseismology. So, paleoseismology is the study of the occurrence, the size, timing, frequency of earthquakes. Paleoseismology can also tell us the amount of offset. Ibig sabihin, gaano kalaki yung pag-move ng mga active faults, gaano kalaki yung horizontal, the vertical displacement, how fast the fault is moving on the average over a geologic time. Paleoseismology requires stratigraphy. Yung stratigraphy is just the layerings of the rocks, structural, geomorphic evidence to reconstruct sequence of displacement. So simple to say, ang ginagawa sa paleoseismology is we look at evidence of past earthquakes. And to do that, what we do is to look at the sources of earthquakes. Kailangan muna naming malaman nasaan yung fault sa ground. And if we know kung nasaan yung fault sa ground, ang ginagawa ng isang paleoseismologist, huhukayin niya yung ilalim ng lupa. And sa ilalim, after the excavation, we can see layers of rocks. Normally, the layers of rocks are deposited horizontally. Kung magkakaroon ng break along these layers, there could be a fault. And if there's a carbon material or charcoal material, we can date that and we can know the date of that earthquake. So malalaman natin yung birthday ng mga bato, yung birthday ng earthquake if we get enough charcoal samples. So this is an example of my excavation or of our excavation showing the very big difference of the left side and the right side, yung boundary between these two layers or these two different layers, yan yung tinatawag nating active fault. So, paano ba nalalaman ng mga geologists ang isang active fault? Maraming faults sa Pilipinas. The reason why we have lots of gold, mga mineral deposits is because we have lots of faults. Pero hindi lahat ng faults are active. We consider an active fault if it has moved within the last 10,000 years or during the Holocene period. So how do we establish this 10,000 years? First is we do historical and contemporary seismicity. We study the historical earthquakes. We study the present seismicity. We identify fault slip based on displaced rocks or soil units of known age. So yung mga changes on layers of the rocks. And we also identify faults by identifying displaced landforms. So what are the tools of a fault finder? Ang tool namin is just, first, we read existing literatures. There could be past studies about these faults. We will hold topographic maps. Yung topographic maps, these are very important tool para malocate natin exactly kung nasaan yung trace ng fault. We also use Landsat and SAR images. So most of you are very familiar about Google Earth, yung Waze. So sa amin, tinitignan namin siya from the top. We use Landsat and SAR images, mga Google Earth images. We also do digital elevation models, aerial photographs. This is an example of an aerial photograph. This one was taken in 1946, showing the old Marikina River. This is Marikina River, and this is the old Quezon City. You can see a very distinct linear feature here, and this linear feature is the location of the West Valley Fault here in Metro Manila. Okay? Yung nasa right, this is the image, satellite image of Mindanao Island. You can see some linear features, and some of these linear features are active fault. So after doing our mapping, mga desktop mapping, using our computers, using our maps, we will go to the field and verify if this location is the exact location, and we do look for evidence na nagkaroon ng movement along these faults. We just look at mga rock samples, we excavate to look for this. So in the Philippines, as we all know, there are many active faults. The longest of which is the Philippine fault. Ito yung mga red lines here, these are faults, and these faults can generate earthquakes na magnitude 7 and above. Almost every island in the Philippines have red lines, ibig sabihin red and black lines, ibig sabihin may mga faults in every region, every province except for Palawan. So far ngayon, wala pa tayong namamapa na active fault. So these active faults, we have Philippine fault, Valley fault, Aglubang. Some of these faults I have studied. One of this is the Philippine fault. This is one of the major active faults in the Philippines. It extends from northern Luzon, dito sa may Ilocos region, going to Masbate, Leyte, and Eastern Mindanao. Dito siya mag-exit sa Mati, Davao Oriental. It's 1,200 kilometers long. Siguro ang nalakad ko dyan ay sabihin natin mga 30-40%. I have exactly walked above the fault. So nalalakad ko siya sa ibabaw. And this fault, we all know, have already ruptured in the past. The good thing about this fault is yung 1,200 kilometers is not moving he's not moving one time. Kumbaga, yung mga faults, yung 1,250 kilometers are segmented. Nagmo-move siya parts by parts, segments by segments. And the longer the segment, the longer the fault, the higher the magnitude it can generate. So a very good publication we have done is yung Philippine fault. We have identified the fault using aerial photographs. And recently, yung minamapa naming mga faults gumagalaw. Okay? One good example was the 2017 magnitude 6.7 Surigao earthquake. This earthquake, alam namin prior to the earthquake that this bridge is being transected by the fault. Yun nga lang, naunahan tayo ng fault. So, ang hazard here is that if you have a structure on top of a fault and that fault will rupture, walang engineering intervention. So, there should be no structures on top of an active fault. This one was during the 2017 late earthquake. You can see here the surface rupture. Tinamaan din itong isang building and lahat ng buildings sa tinamaan niya were also damaged. Hindi na siya mapapakinabangan. We also mapped this fault previously. Kilala kami ng mga tao dyan during the 2017 kasi halos every year pinupuntahan namin just to study this fault. Last year, there was also an earthquake in Masbate. And this Masbate earthquake, ang last earthquake niya was 2003. Then, after 17 years, naulit-uli yung earthquake na magnitude 6.5. And this is an example of the surface rupture wherein it displays these rice bodies. On Eastern Mindanao, there are different segments of the fault. Ang importante dito is that if you know the location of the fault, pwede mong maiwasan yung fault. Hindi kayo magtatayo ng structure on top of the fault. If you know the segment length, yung haba ng fault, you can estimate the maximum credible earthquake or the earthquake it can generate. The maximum earthquake, then we can tell you gaano kalakas yung intensity ng earthquake, what will be the maximum intensity that will happen if that segment of the fault will move. So we have a segmentation for this Philippine fault in Eastern Mindanao. Isa sa mga nagawa naming mapa was the Valley Fault System. So this is very famous in Metro Manila and even in the Philippines. And this fault, ang haba niya is 100 kilometers in length. In some areas, together with the local government units para maiwasan ng mga tao or malaman another awareness ng mga tao is they put up markers. So this is an example of a marker doon mismo sa kalsada and sana hindi pa siya nabubura but you can easily identify kung nasaan yung mga faults. You can be a fault finder. You just go to these two websites, faultfinder.phivocls.dost.gov.ph and hazardhunter.geologist.gov.ph. You just visit these two websites. Yung red line is the trace of the fault. You look for your house. Hanapin nyo yung bubong ng mga bahay nyo. You just double click it and then we will tell you how far you are from the trace of the fault. Ang safe, dapat walang structure na nasa ibabaw ng fault. You have a buffer zone of at least 5 meters away from the edge of the fault or the edge of the deformation zone. So after knowing the trace of the fault, ang gagawin ngayon ng mga paleoseismology is to excavate. Yung excavation will tell you, will identify the number and timing of previous surface rupturing earthquakes. So as an example is these layers of rocks, yung topmost layer is half a meter below the surface. So ibig sabihin, this fault have already moved at least 4 times in the past 2,000, 3,000 years based on the charcoal samples. Using this, we can determine the recurrence interval. Recurrence interval means we can determine the repeatedness of earthquakes. If we know the repeatedness of earthquakes, aalamin lang natin yung last earthquake and then we can assume kailan yung susunod na malakas na lindol. And this paleoseismic investigation can be used for seismic hazard assessment. So, paano ba namin nalalaman or paano tayo naghuhukay? We go to the field, we identify, for example, this site is the identified surface rupture of the 1879 Surigao earthquake. Paano namin nalaman? First, we use aerial photographs. Then we look at the historical documents of 1879. And from the 1879 event, there were documents na nagkaroon talaga ng surface rupture. Based on aerial photographs, we also identify offset river terraces. So yung mga na-offset na mga landforms, we can identify that on mga aerial photographs. Then we will identify or we will look for a good site. Hindi lahat ng may fault ay pwedeng hukayin kasi pwede mo nga siyang hukayan, makikita mo yung fault, but that is not a good site. You have to select a proper site para i-excavate natin. Either we excavate it manually, so hinuhukay namin siya mano-mano. May mga kasamahan tayo na taga doon sa community, they help us to excavate it. Ang lalim niya is around 3 meters yung depth. The width is around 5 meters and the length is around 10 meters. Ganun yung length niya. And we will clean the trench and you can see this very beautiful displaced landforms. And from these beautiful displaced landforms, we can identify kung nasaan yung fault na nasa ilalim na ngayon. Then we can also use mga backhoe. So mechanical, mas mabilis, pero mas matrabaho, mas mahal. We need to clean it. This is an excavation we have done in Maragusan, Davao de Oro. And then using this mga layers of rocks, this trench walls, we can identify yung faults, the red lines here. If there's enough charcoal samples, we can know the age of the rocks. We can know the last earthquake or the penultimate earthquake, and we can determine the recurrence interval, all the repeatedness of earthquakes. So very simple, ganun lang yung gagawin natin. And then after that, we can report our results. So this is a paper we have published on February 6, 2017, talking about the Surigao segment of the Philippine fault. So take note, available online February 6, 2017. And after that, few days after, nagkaroon ng lindol. There was an earthquake on that segment of the fault on February 10, 2017 with a magnitude 6.7. So, ang maganda ang medyo nahuli, but we know based on science, we know the recurrence interval, we know the location of the fault, and kung tama yung gagawin ng local government units, we can mitigate the impact of these earthquakes. These are some of the results we have conducted na mga studies. Yung recurrence interval of the valley fault system is approximately 400 to 600 years. So using this, we know that yung mga old earthquakes happened prior to 1658. Hindi lang historical yung nangyari, but prior to 1658, there are at least 4 events or 4 earthquakes for the past 1,400 years. Based on paleoseismic study, we have known that the 1645 event was a result of an earthquake along the Gabaldon segment of the Philippine fault. Yung trench natin sa Maymati segment located in Davao Oriental, we all know that the recurrence interval is 400 to 1,000 years. And historically, this segment have never moved. So ibig sabihin, there's a potential that this Mati segment may move during our lifetime. And for the Philippine fault in latest segment, alam natin that it has a shorter recurrence interval. Around every 60 to 120 years, pwedeng magkaroon ng malalakas na lindol diyan sa may Leyte. So thank you very much for listening, and maraming salamat. Thank you.